Hello students. So today we're going to talk about lasers. Okay. So what does laser stands for? Laser stands for light amplification by stimulated emission of radiation. So the full form of laser is light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. So what does it mean actually? So you can just look into this. Light amplification means there is an amplification of light by the process called stimulation emission of radiation. So what is getting amplified? There's some kind of radiation is getting amplified. So laser stands for light amplification by stimulated emission of radiation, which means amplification of light by the process called stimulated emission. Okay. So this is the basic theory behind laser. So we'll look into. So I introduced a word called stimulated emission. So we'll get into things into directly. So whenever imagine this theory was given by the greatest of all physicists, of all time. That is Sir Albert Einstein gave this theory of stimulated emission, and it the the theory was given by him, and it took about 30 to 40 years to make it an instrument. Okay, initially the first instrument called maser. So maser means M stands for microwave. Okay, so they made an instrument which is a maser. Micro M stands for microwave. So microwave amplification by stimulated emission of radiation. And later it was done with light. So it becomes laser. Okay, light amplification by stimulated emission of radiation. So Einstein just thought that, see, we'll just consider an atomic system. Okay, so whenever a light falls, consider an electron or an atom is in the lower state. Okay, this is the ground state. Whenever a light be represented by a wave, because light is the has a property of duality, that is it acts as a particle and it acts as a wave as well. So whenever, let us consider a light of energy h nu, where h is a Planck's constant, nu is the frequency of this light, which is actually equivalent to E2 minus E1, where this is the ground state energy and here higher state energy. So E2 minus E1, let us imagine. So whenever a photon of energy h nu, photon is light, packet of light, which is made to fall on the atomic system, it just elevates to the higher energy state. It just elevates to the higher energy state. So what is happening? We are making this process to happen, right? We are just stimulating it. So this kind of phenomenon is called stimulated absorption. Stimulated absorption. So we are stimulating this process. Okay, so what is happening? A photon of energy h nu is made to fall on atomic system where the atom is in the grounded energy level, and as the photon hits the system, it absorbs the energy and it elevates or it excites to the higher energy state, and this process is called stimulated absorption. Okay, this is the first kind. Now we'll move on to the second kind. So we'll imagine the atom is already in the higher energy excited state. Okay, so what happens? See, everyone, that is maybe humans or animals or anything in this matter, in this universe, it can't be always in some kind of excited state. It has to come down at any point of time. So Similarly, an atom or an electron which is in the excited state cannot stay there for a longer time. It will be coming back, or it will be jumping down to the lower energy state with the emission of certain radiation which is equal to the initial radiation. Okay, that is h nu. Okay, so giving out whatever the energy has absorbed, and this process, the jumping of an electron from atom from an higher energy state to lower energy state without an external agency by itself, is known as spontaneous emission. Spontaneous spontaneous emission. Spontaneous emission. Okay, so this process is called spontaneous emission. So you understood what is stimulated absorption and spontaneous means something which happens by itself without any help of some other external agency. So what is happening here? An atom which is already in the excited state jumps back to the ground state with emitting the incident radiation, and this process is called spontaneous emission. And there is a time um, at which the electron stays there in a particular energy level. So this process is called spontaneous emission. This is the second kind. So with this phenomenon happens by itself. The third kind is, imagine we have an atom in the higher energy level and it is staying there. This is an energy level E2 and energy level E1. So we are again passing a photon of energy h nu. So at this time, what happens? Because of this incoming photon, the atom is forced to come down to the lower energy state, by in turn giving out two photons. Okay, one the initial photon and one the initial photon which was responsible for the excitation, and the one, this is the second one. Okay, so here you can see the out the whatever the radiation which is coming out is in phase. It's highly intense, monochromatic, coherent beam of light. Okay, and this radiation which is coming out, which is highly intense, monochromatic, coherent beam of light, is known as, simply called as, laser. So simply, what is a laser? Laser is a highly monochromatic intensity, a highly intense monochromatic beam of light, coherent beam of light is called laser. Okay, so what do you mean by monochromatic? It means it is single colored, and highly intense means it is highly directional. Highly intense. Highly intense means highly energetic, and it is highly directional means it is not, dispersion is very less. Okay, it is more of narrowed. Then coherent means the the waves are in, or the photons are in phase. That is, crust and crust are coinciding, and trough are said to be coinciding. Okay, so these are the three things. So let us just glance up once again. So this laser is mainly based on the phenomenon of the last one which we studied, that is stimulated absorption. Stimulated Stimulated emission. So I think now you have an idea how this laser works. Laser stands for light amplification by stimulated emission of radiation, which means amplification of light by the process of stimulated emission. Okay, so as you have seen, the atom, when it comes down, it gives uh, an highly intense monochromatic beam of light called laser, and which is called laser. Okay, and the process by which an atom is forced to come down, okay, we are giving some stimulation, so hence it is called stimulated emission. emission. So this is the basic principle or basic theory behind laser. So based on this, we have built up many kind of laser. Many any some thousands and thousands number of lasers have been so far. So basically, we have majorly we have from 7 to 8 types of lasers, and from that they have we can create some n number of radiations to you can produce a number of radiations through these lasers. Yeah, I think that's all for today. Thank you.